We're in Rosen, section 4.2, Discrete Mathematics and its Applications, um, discussing binary addition of integers here. And in a separate video, we did a derivation to talk about how to uh, construct an algorithm for doing binary addition of integers. And here is the algorithm for doing so. And if we have two in-length bit strings or two in-length binary integers, we would add them up just like you would regular addition from right column over to the left column, starting with the first bit in this case, and the last things you would do would be add the columns with the leftmost bits. And we'll set this up as a loop. So we'll start with the leftmost column, and we'll have an implied carry digit of 0 for that leftmost column. And then, as I said in a separate video, we derived what the formula for the carry bit. And then we use that carry bit. We also derived the formula for the sum bit to write down. And so the way that looks is we have, for the jth column, we have j, a sub j, and b sub j. And then the carry bit from the previous column is there. And so this is some could be in the middle of our binary integer. And then we would first calculate the carry bit. We would calculate d for that column j. And then once we know d, we can calculate the sum bit or the write down bit s sub j. Okay? And if you didn't see that other video for the derivation of these, please check that out. All right, so once we have each of those sum bits, we will the very last one will be the carry bit from the last column or the leftmost column. All right, one of the things that we want to be able to do is to figure out how complex an algorithm is. And if you have not studied algorithmic complexity, that is in chapter 3 of the Rosen text, that is prerequisite knowledge. And if you don't remember it, please take a look at it. One of the things that we are looking at here is how many additions does it take to add up two n-bit integers. Well, let's take a look at our equations here. We have an addition there, we have an addition there. I see 4 pluses and then a minus is the type of addition. So just with additions, there's 5 additions that take place inside of each loop, and then that loop is going to execute n times. So the number of additions is equal to 5n, and that is big O of n in terms of complexity. Okay, all right, let's take it to the next level and talk about binary multiplications of integers. Here we're still dealing with two n-digit binary integers. And then the way this will work is we're going to, for every multiplication that will take place will just be a shift. So we're going to take a, and for every b sub j, we're going to create a new number c sub j that's a shifted j places, if b is a 1. Otherwise, it'll just be a 0. So that if you have 1, 0, 1 times 1, 1, the first thing you write down is, this was a, this is b. The first thing you're going to write down is 1, 0, 1 shifted in 0 places. But then for the next one, you're going to write 1, 0, 1, and then there's an implied 0 here. That's a shifted 1 place. And if I had a 0 and then a 1 here, I would get a 0 for that third row. So this is going to be C sub 0, this is C sub 1, this is C sub 2, and C sub 3 would be A shifted 3 places. So 0, 0, 0, 1, 0, 1, that'll be C sub 3, okay? But in every case, we're just basically writing down A and shifting it over. Now, what we're going to do is take all of these C sub j's and we're going to accumulate them into this p variable here. And so we'll start with j sub 0 and add c sub 0 to p, and then we'll add c sub 1 to p, then we'll add c sub 2 to p, and eventually p will accumulate all of these c sub j's. Well, what we don't see here is that this is an addition, but it's not our binary addition algorithm. We're just basically adding these numbers. But in reality, we know that this is big O of n operation, and it's inside of a loop that is of length that has going to be executed n times. So the result of this will be something that is big O of n squared operations. Okay. If you want to think about it, since we potentially shifting our numbers, basically doubling the length of them, the additions are going to be fn is going to be 10n because we're potentially doubling the length, and then we're going to execute that n times to get n squared, which is big O of n squared. Okay. All right, and that is binary multiplication and binary addition of integers and the complexity of those operations.